Hello, everyone. Thank you for joining again. We are starting a new series which is focused around the OpenStack training. I have seen there are a lot of vendors who are providing the training, but I feel this is something an open source project. So I've decided to put together and go through a complete OpenStack training, starting from the basics of what is the OpenStack and doing a deep dive into different projects, followed by the hands-on lab exercise. So this is the part one of this OpenStack training, and on this I will be focusing around what is OpenStack, some of the overview of the OpenStack. Feel free to leave me any comments, and I would be more than happy to answer any specific questions you got, or let me know if you need some more details into the presentations later on. But just keep in mind one thing, that I will be doing individual presentation on every topic followed by a detailed hands-on lab. So let's go ahead and start this initiative onto this training, and we're going to talk about the OpenStack. So let's go ahead and start and understand what is OpenStack. So I know a lot of already what is OpenStack, and there is a plenty of information available on the web, and I have picked up the very simple definition from the OpenStack Foundation. So what is OpenStack? And as per the OpenStack Foundation, OpenStack is nothing. We are aiming to produce an open source cloud computing platform, which basically meets the need for the public, private, and hybrid clouds. Regardless of the size, when we say talk about the size, it could be a very small company with a few hundred VMs, or maybe a large enterprise or a service provider running multiples of thousands of the VMs or the instances. And at the same time, when we talk about the size, we need to keep few things in mind. It should be very simple to implement and massively scalable. So anytime there is a demand, we are running out of the compute resources, we are running out of the storage resources, we should be able to provision them on demand. So that's what is all about the OpenStack. There are a few other definitions that you could find, and pretty much they all talks about what is OpenStack. So OpenStack again is a cloud computing project aimed at providing an infrastructure as a service, IaaS. Again, OpenStack is an open source infrastructure and application middleware for building private, public, and hybrid clouds. OpenStack is an cloud operating system or framework that controls large pool of compute, storage, and networking resources throughout a data center. OpenStack is backed up by a global community of technologists, developer researchers, corporates, and cloud computing experts. People like you and me also can be part of the OpenStack community. If you're good with the programming, you could write your own patches, or maybe can contribute towards some of the bugs, or maybe help with the community with some of the documentation, or just like what I'm doing in providing a free training to the community. So you could be part of the OpenStack. So hopefully by this time now you know what is OpenStack. One thing to keep in mind always, the OpenStack is nothing. It's going to provide infrastructure as a service. So we are talking about the IaaS over here. Let, let's it's good to learn a little bit of the history and how this all things came to the lights and everything. So initially NASA had a project by name Nebula, which was nothing but a scalable cloud compute project they were using internally, which was not publicly made available. And at the same time, Rackspace, which is a hosting company, had a scalable object storage cloud solution by name Swift. So they both came together, and the first release came in November 2010, and the releases are named after the city or the places where the meetings were held. So Nebula is a the all of these projects, and that foundation is nothing but the OpenStack Foundation. Every release cycle, initially when the project started, the release used to be like every 3 months, but now the released are released every 6 months. And the version numbering is pretty straightforward. There's a year and dot release underscore number. So you will find people referring like 2010 or 2013 or 2014.1, 2014.2, and so on. As we mentioned earlier, the OpenStack, the first release came out in October 2010, and you can see the name started with the Austin. After that, the Baxter, Cactus, And right now we are into version by Juno, which was recently released on the 16th October 2014. So if you notice, the names also has a pretty common thing. They all start with like a alphabet A, B, C, D, and so on. And these names are given based on the places where the meetings were held, and that's how they came up with all these naming conventions. Right now, there is a work going on the project by name Kilo. So the tentative dates for that to be released somewhere next year, April, March or April. But that can change. But looking at the way they have been releasing, it's pretty much every 6 months. There are a few guiding principles the OpenStack Foundation follows. So those founding principles are nothing but refers to simply four O's. So when we say four O's, we are talking number one. It's an open source. That means the all code that is being used by the OpenStack is licensed under Apache 2.0 license. That means anybody can freely download and use under Apache software in whole or in part, and they can do anything with that one. It's an open in design. That means, like as we mentioned earlier, anyone can attend or code. And we know that there is a process it has to go through, but in general, the design is pretty much open. And the summits held 2 times per year. Again, it's an open development, so all the code is available to you. You can go to this URL, github.com, OpenStack. You can see what they are doing, what are the different, you can create a branch out of that. You can contribute to that one, or you can even help in a bug fix. You can provide your own patches back to the community. So the development is pretty much open. Again, it's an open community, so all the documentation and everything is available at the docs.openstack.org. You can pretty much ask the questions. If you hit any kind of roadblocks, you can go to ask.openstack.org and questions. And that's what that's what is making the OpenStack pretty popular, because their guiding principle are these four rows. So always keep in mind the OpenStack is an open source. Open their own variations based on the OpenStack, but whole as a pure project as a majority is open community based. Within the OpenStack, there are different projects that makes up OpenStack as a cloud computing platform or cloud computing framework in a general. So these projects have different names that you can see on the slide. We have a project by name Keystone, which is nothing but provides an identity services. And folks, keep in mind, I will be doing presentations on every project with the greater detail that will talk about the project in details, how the project works, the API, the architecture, the flow, followed by a hands-on lab. So keep your questions till those presentations when we go into the much details later. So we got the identity project by name Keystone, Compute, Nova, Networking. Nowadays, it's new name of the Quantum, or pretty much a lot of people are still using like Nova Networks too. We got an object storage. The project name is Swift. We have a block storage. The project name is Cinder. Glance, which is our image service. Horizon, which is in the dashboard. For metering services, where you can measure who's using how much and what they have been using, the project name was Solometer. Recently, that was renamed to Telemetry. We have an orchestration service by name Heat. Now, with the Juno release, we have a database as a service. The project name is Trove. And we do have a data processing project too by name Svena. So again, we will be focusing on these components or these projects much into the greater details. But let me give you a liner about every project, what that project does. So the Keystone project is the identity project. It's the identity responsible for pretty much authentication and authorization piece over here. Noah, compute responsible for providing the compute to our instances. So instances are nothing but spawning a new VM. Neuron is the networking piece responsible for handling all the networking functionality. Swift object storage, if you are looking for an object storage where you want to store your data into the form of objects and just want to retrieve, you could use Project Swift. Cinder, block storage, anywhere you are looking for a persistent storage, you can look out for the Cinder project. The glance image service. Images are nothing but the ISO or the snapshot that you are storing, and using those ISOs or images, you could spawn a VM. Variety from the command line, a lot of things can be done with the GUI. So that is something that you can give it to your end user with certain privileges, so they can probably go ahead and create their own VMs and some of the other things. At the same time, we want to measure. So metering service, telemetry or slow mirror is just a mirroring. It's not a billing service where you can pull up some data, just and you can pretty much use that data later on to pass on to some of another customized billing engine or maybe to Excel sheet and come up with some kind of invoice and billing. Heat is our orchestration service. Orchestration, let's say on a demand, you got a web server and there is some special event is going to happen, and pretty much you can the orchestration or the on the fly. So you can define the limits, and the orchestration heat project works very close with the telemetry. Telemetry can raise some alarms. You have workload of 50% on your web server, and you can define some triggers. Based on those triggers, you can pretty much call your orchestration service, and it will help you to spawn another web server. So that's how you can bring up the VMs or the workloads on the fly. Trove database service, as I mentioned, that is something came up with the Juno release. Pretty much you can now have the your database also as a service. Swana is for the data processing. So we will be going through these projects later in much detail. Thank you. That's all for this presentation. Hopefully, this presentation you have a very good understanding OpenStack, from where the OpenStack came, what is the OpenStack really its cycle, and what are the different projects in the OpenStack. If you need more details, feel free to leave me a comment, or you can always go back and check out the docs.openstack.org. Has plenty of information. Uh, there are plenty of blogs are available. There are a lot of knowledgeable people, or you can go back to the YouTube and you can subscribe to the OpenStack Foundation's YouTube channel that has very good information. So again, thank you so much for taking your time and joining into this one. I'm looking forward for your feedback. Thank you. Bye-bye.